Okay, so I put the title, The Gravity of the Situation. This problem has to do with gravity. So it's a very classic problem in college algebra. Okay, so it says a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. Okay, so here's a building, and then this person's standing on top of the building, apparently a very tall person. My people always get hats. And he has this ball, or she, and they're going to throw it up. But it's only going to go up so far because gravity is going to kick in and it's going to come down. So, and you can kind of see the parabola there. And it depends on kind of if you throw it straight up, like how much the parabola is going to look. But anytime you're dealing with projectiles, you're shooting an arrow, you're shooting a cannon, or hitting a ball off a bat, all of those are going to be parabolic because of gravity, okay? So anyway, that's what's happening with this person. They're on top of the roof. They throw the ball up. Now, it says the ball's height. And so the ball goes up, ball comes down. Okay. And eventually it's going to hit the ground. The ball's height above ground. Okay, so when you say, all right, the ball is right here, that distance is the height, okay, based on how long it took. So the person throws the ball up in the air, and after so many seconds, it's going to reach that height. That's what our function is. The height of t equals negative 16 t squared plus 80t plus 40. Now you can see the 80 in the problem. That's the thrust. That's how fast he's throwing the ball up in the air. The 40 represents the height of the building. You might be wondering about the negative 16. That has to do with gravity. Okay, but anyway, that's probably more information than you wanted to know. But this is our quadratic function, right? When does the ball reach a maximum height? Well, then we want to know the vertex, right? Anytime we're doing a maximum or a minimum, we want to know the vertex. So, vertex. Okay, so the opposite of b over 2a, we know to do that. So I'm going to have negative 80 over 2 times negative 16. Well, 16 goes into 80, I'm pretty sure 5 times. And so it's going to be negative 5 over 2. Oh, no, it's not. It's going to be positive. Oops. It's going to be 2.5. I'm going to go ahead and go with a decimal with this for this one, okay, because of the nature of this problem. Now, what does that mean? Well, you can say, okay, my vertex is 2.5, comma, and then I'm going to figure out h, oops, not f this time, h of 2.5. So it's going to be negative 16 times 2.5 squared plus 80 times 2.5. I'm skipping the fraction work this time, plus 40. Okay, I'm going to stop this video and do that on my calculator. Okay, I'm back, and I got h of 2.5 equals 140. Okay, so calculator work. What does all that mean? Okay, so my vertex is 2.5, 140. What was the input? The input was time in seconds, okay? The output is the height. Oops, h of t. So what do we want to know? It says when does the ball reach the maximum height? After 2.5 seconds. So I wanted to know when. Well, I don't know why I have a comma there. After 2.5 seconds. I'll write out seconds. Okay. Okay, so you throw the ball up, and it goes up for 2.5 seconds. It reaches the top of how high it's going to go up, and then it's going to start coming down. What's the maximum height of the ball? Well, that's the output then. So we already figured it out, 140 feet. All right. When does the ball hit the ground? So in other words, when does our function, negative 16t squared plus 80t plus 40, when does that equal 0? Because that's when the height's going to be 0 when it's hit the ground. Okay, so this is the height is 0, so, or it's on the ground. Okay, so hopefully that makes sense. Okay, 16 doesn't go into 40, darn. All right, so I guess we have to use the quadratic formula. Anyway, there's other ways we could do this, but I'll just use the quadratic formula. Not what I wanted to do. Oh, you know what? I could simplify it, couldn't I? I could divide everything. I mean, 16 doesn't go into all of them, but 8 does, right? Okay, so let's divide everything by 8. Let's see if that gives us anything that's factorable. Okay, -2. Ooh, let's do it by a -8. You don't have to. You could go to the quadratic formula. You probably have it done before me. But if I divide by -8, then I can have 2t squared minus 10t minus 5 equals 0. So two numbers that multiply to be -10 and add to be -10? Yeah, I don't think so. Okay, so let's go for the quadratic formula. But at least our numbers are smaller. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that's going to be, let's see, 10 plus or minus 100 plus 40 over 4. Or 10 plus or minus square root of 140 over 4. Now, let's think about this a minute. What do we think the square root of 140 is? We can do that on a calculator real quick. Let's see what the square root is. The square root of 140. It's 11.8. So the square root of 140 is about 11.8. That means I cannot take the negative case, because then I'd be having a negative time, and I'm not going to have a negative time. So 10 plus the square root of 140 over 4. Now, do they want an exact answer or a decimal approximation? That I'm not sure. It makes more sense to do a decimal approximation, but let's see what we get here. Let's see, 140, that should probably simplify. 4 goes in, let's see, 4 times 35. Okay, so 10 plus 2 times the square root of 35 over 4, which would be 5 plus the square root of 35 over 2, but that answer is just not very practical. Like, you wouldn't go to somebody and say, okay, what was the question? When does the ball hit the ground? Well, it's going to hit the ground in 5 plus the square root of 35 over 2 seconds. So let's get a decimal approximation. 5 plus, which we could have done earlier. Just used our big numbers. And I'm just doing this on my calculator. So I'm going to say about 5.46 seconds. So that's how long it's going to take for the ball to go up and then hit the ground. Okay.